Note down. So let's continue Newton's laws of motion. So today we'll discuss constraint relation. Note down. Constraint relation. Okay. Constraint relation. Constant relation for connected bodies. For connected bodies. Connected bodies means suppose two blocks are there, they are connected by a string, right? So let's take very basic example. Suppose this is the horizontal surface and two blocks are there, block A and block B. They are connected with the help of a string. This is a string. The string is connecting A and B. So if you pull A left, so B will also come. If you pull B right, A will also come. Correct? Why? Because string is there, it is connected. So displacement of B, suppose 1 meter. So what is displacement of A? 1 meter. Correct? If displacement of B is x, so displacement of A is also x. Correct? Whatever is displacement of B, same displacement of A. So both displacements are equal. Both displacements are equal. Correct? So constant relation means we will relate their relation of displacements. Okay, displacements relation. Then we can say speed also. Like for example, B is going right side with 1 meter per second. So what is the speed of A? 1 meter per second, because they are connected by a string. Correct? What if I consider a pulley? Now this is a pulley, this is a clamp, ceiling. Now a string is going over this pulley like this. This is the string. Now the blocks are connected like this, A and B. Now you tell me, if you move B, suppose B is moved down, where A will go? Upward. Very good. Suppose B moves down by 1 meter, so A will move up by 1 meter. Correct? So you can say displacement of A is equal to displacement of B or minus of displacement of B? Minus. Correct. Good. Displacement of A is minus of displacement of B. Okay, note down. Draw this diagram. If B is going down, so A is going up. If B is going up, so A is going down. Because length of string is fixed. Length is fixed. Yes. Length of string is fixed. If this part of the length is increasing, so this part of length is decreasing. Suppose this length is x and this length is y. If y is increasing, x is decreasing. Correct. Because x plus y is constant. X plus y is constant. Correct. So if y is increasing, x is decreasing, right? Because b is going down, a is going up like this. Now, for example, You can say, suppose I am saying B is moving down with 1 meter per second. So what is the velocity of A? 1 meter per second upward, correct? So we can write velocity of A is minus of velocity of B, correct? If velocity of B is 1 meter per second downward, so what is velocity of A? Like this, minus of minus 1, so plus 1. VB is minus 1, downward means negative, right? Upward means positive. Are you getting, everyone? So similarly, if you differentiate this, what you get? If you differentiate, so dVA by dt is equal to minus of dVB by dt. So when you differentiate velocity, what you get? Acceleration. Now what is this? Acceleration of A is equal to minus of acceleration of B. So note down, acceleration of A is minus of acceleration of B. When the pulley is fixed, this is the fixed pulley. Fixed pulley. Clamp is fixed, ceiling is fixed. Pulley is fixed here. It is a smooth pulley, right? Smooth, smooth pulley, small pulley. It is not rotating, because for rotation of pulley, what is needed? Friction. So it is a smooth, so frictionless. So pulley will rotate or not? No, it will not. Okay. It is a small pulley, and massless also we consider massless. Pulley is massless, correct? So if B is going down, A is going up. If A is going down, B is going up. Okay, like this. So displacement of A is minus of displacement of B. Velocity of A is minus of velocity of B. Acceleration of A is minus of acceleration of B. So this is one example of constraint relation. Constraint, right? They are connected. Constraint is related to connected bodies. Okay, A and B are connected or not? Connected. They are connected with the help of string. String is there. Okay, fine, clear. Okay, next. See, next. Suppose this is the clamp. This point is fixed. This is the floor. Now you have one block here. Now you tell me, what are the accelerations of these 2 points? Suppose this point is 1, this point is 2. What is the acceleration of 1 and 2? It is fixed here. This point is fixed here. So this length of the rope is constant. Ceiling is also fixed. Ceiling is fixed. Floor is fixed. So this length is also constant. So this length is also constant. So what is velocity of A? 0. A cannot go up or down, right? Because if you try to move A down, the string will break, right or not? The string will break. So we are not considering that. Okay, the string will not break like that. So what is the acceleration of A? It is 0. What is velocity of A? 0. So A is not moving. A is at rest. So what is acceleration of this point? It is not going anywhere. It is here only, rest only. So what is acceleration of 2? It is 0. Acceleration of this point is 0. What is acceleration of 1? That is also 0. Okay. So if the string is connected to floor, correct? So the point has 0 acceleration. This point, this point, this point, all these points are at rest. Correct? So point 1 is at rest. So acceleration of 1 is 0. Note down. Acceleration of 1, 0. Acceleration of 2 is also 0, because all points of the string are at rest. All points of string are at rest. So acceleration 0. Okay, all points of the string are at rest. Like that string, that is at the rope is there. All points of that rope is 0. That string is rest. Okay, all these strings, all points are at rest. Okay, so acceleration 0, velocity 0. Correct. Next example. Now this is the fixed floor. Fixed floor. One pulley is there. This is block A. Now there is another string connected here. So how many string you see? This is one string. Second string, total strings, 2 strings. Okay. So you can call it string 1. This is string 1, and this is string 2. Now you tell me the A is at rest or it can move. A is at rest or it can move. Tell me. A can move up or down? Yes or no? No. Why? Because this point is at rest. And so this point is also at rest. And what about this point? Rest. So these points are at rest. This point is at rest. This point is at rest. This point not going up and down. This point not going up and down. So this point is also not going up and down. So this point is also rest. So acceleration of A in this case 0. Acceleration 0. Correct? Acceleration of block is 0. It cannot go up or down. Okay? Because suppose if it is going down, suppose it is going down. So this point is going down and this point is at rest. So this point will also go down, but it is fixed. This point is connected here. Ceiling is fixed. So this portion of the string is fixed. Correct? So this pulley is also fixed. Pulley is also fixed. Pulley cannot go up and down. Correct? Okay. So block is at rest, pulley is at rest, all the strings, all points of the string are at rest, rest. All points of the string are at rest. Okay, understood? So you have to observe. You have to observe. See it. Where is the point of the, where is the end of the string? End of the string is here. Fixed with ceiling. So this end is fixed here. So this end fixed. So pulley is also fixed. And this end is fixed here. Fixed. So all points are fixed. Correct? All points are fixed. Okay. Note down. Next. So one ceiling is there, one floor is there. And let's take one example. One pulley is there. Let's take, okay, one pulley is there. Here also one pulley is there. Now here is one block A. Here another block B. Like this. Now I I am considering some points 1, 2, 3, 4, 5. Okay. You tell me which point at rest. Which point at rest? Not moving. One is moving? No, one is not moving. One is at rest. What about 3, 4, 5? 5 you can tell. Rest. Confirm. Okay, confirm, not moving. Always. Rest always. Okay. 5, rest always, because this is the clamp. Clamp is fixed. This is fixed ceiling. Fixed ceiling, fixed floor. This is fixed floor. Floor is fixed. Ceiling is fixed. This point is fixed. This point is fixed. Fixed point. So these points are fixed. All these points are fixed. But 3, 4 and 2 may be moving, may not be moving. See, I will give one example. Suppose you try to pull A down. So point 2 will go down, 3 will go down, 4 up. If point 2 is going down, point 2 go down, 3, the pulley will also come. See, if A is moving down, so pulley will also come down, and 3 will come down, and 4 it will go up. Correct? Are you getting? If A is going up, if point 2 is going up, so this pulley go up, 3 go up, so 4 go down. Correct? Now how to solve this? So there is a relation also. Now we will see the formula. What is the formula for the pulley? Okay. Now you observe, this is the pulley. 1 point here, 1 point here, 1 point here. Now this is the pulley. 1 point here, 1 point here, 1 point here. Okay. So 3 points we will consider for a pulley. 3 points. So how to find relation between these 3 points? Acceleration of these 3 points. So see. So you observe again. So confirm we are, this is rest, but these 3 can move. If this is going down, so this is going down, this is going up. Okay, fine. Okay, so see, now this is the pulley. Now you draw this diagram. Suppose this point is, now 3 points you have to consider, 1, 2, 3. 1, 2, 3. Now this is the pulley. So if point 3 is going up, so pulley will go up. If point 3 is going down, so pulley will also go down, because this is the string. Okay, this is the string. Now you see, if with respect to pulley 1 is going up, so with respect to pulley 2 will go down. If 1 is going up, 2 is going down. If 1 is going down, 2 will go up. Are you getting or not? 2 is going up, 1 going down. Okay, clear? So I will write acceleration of 1 with respect to pulley, and pulley and 3 same. Acceleration of pulley is same as acceleration of 3. So acceleration of 1 with respect to pulley is minus of acceleration of 2 with respect to pulley, and pulley and 3 are same. So we can say acceleration of 1 with respect to 3 is equal to minus of acceleration of 2 with respect to 3. Now what is the formula for A13 in vector form? What you write? A1 minus A3. Remember, in vector it is, okay? And minus of, and what is this? A2 minus A3. So A1 minus A3 vector is equal to minus of A2 plus A3. So what is relation now? A1 plus A2 is equal to 2A3. So A1 plus A2 by 2 is equal to A3. Note down. Remember, upward means plus, downward means minus. So A1 plus A2 by 2 is equal to A3. Acceleration of this point plus acceleration of this point, sum divided by 3, divided by 2 is equal to A3. A1 plus A2 by 2 is equal to A3. Okay, note down. So this is the relation between accelerations of 3 points. So 1 point here, 1 point here, 1 point. 3 points are there. This point and pulley, same acceleration. Center of pulley, this point, if both are going up or both are going down. Okay. With respect to pulley, 1 going up, 2 going down, or 1 going down, 2 go. Okay, fine. So let's solve some questions based on this formula. And if acceleration is upward, you take positive. Acceleration downward, negative. Okay, remember vectors, upward, downward. Okay, rightward positive, leftward negative. Okay. So if 1 is going up, 2 is going down. With respect to pulley, you can write if you want. With respect to pulley, if 1 goes up, 2 goes down. That's why minus sign is there. Okay. Direction of 2 is opposite to 1. Direction of 2 is opposite. If 1 is going up, 2 is going down. If 1 is going down, 2 is going up. Okay, fine. Clear? So let's do some direct basic questions based on this. So solve this question. Suppose this is the pulley. This is the string. This point is 3. This point is 1. This point is 2. Okay, point 1, 2, 3. Now suppose 2 is going up with 2 meter per second square. 1 is going down with 3 meter per second square. What is the acceleration of 3? Calculate. What is the acceleration of 3? How will you solve? Acceleration of 3 is equal to A1 plus A2 by 2. What is A1? Downward. So minus 3. What is A2? Plus 2 by 2. So what is the answer? Minus 1 by 2. Minus 0.5. Minus 0.5. Okay, clear? It is a question now. What is the acceleration of 3 if 1.1 is going down with 3 meter per second square? Point 2, this is the point 2 on the string. This is the string. Point 2 is going up with 2 meter per second square. So point 3 will go down with 0.5 meter per second square. 0.5 meter per second square down. Acceleration of 3.3. Okay, clear? Suppose this is the pulley. Next question. This is the wall. Now this point is 1, this point is 2, and this point is 3. Now point 3 is going right side with 2 meter per second square acceleration. What is the acceleration of 2? If this wall is fixed, this wall is fixed. Now calculate. Wall is fixed. So what is the acceleration of this point? 0. So A1 is 0. What is the acceleration of point 3? 2 right side. So plus 2. Okay, plus 2. Now acceleration of 2 you have to find. What is relation between acceleration? A1 plus A2 by 2 is equal to A3. Now solve. What is A1? Put here 0. A2 you have to find by 2 is equal to A3 2. So what is the value of A2? 2 into 2 4. Okay. So 4 meter per second square. No doubt 4 meter per second square. 2 examples. So question can be like this: vertical. Strings are vertical here, and here strings are horizontal. No doubt. Just remember this formula. Okay, A1 plus A2 by 2 is equal to A3. So this point is at rest because fixed wall is fixed. So this point at rest. This string is going over like this. This is the string. Okay. Now this is the pulley. Another string is there. So this is the string. This string is going right with 2. So what is the acceleration of point 2? Okay. So point 3 is going right side with 2. So A1 plus A2 by 2 is equal to A3. Okay, clear? Understood? Yes. So answer is 2. 2 into 2, 4. So that means one more meaning is there. We can relate displacements also. If point 3 goes 1 meter right side, so what is the displacement of point 2? Acceleration is double. So 2 meter it will go. Okay. So because A2 is 2 times of A3. See, A1 is 0. A1 is 0. So A2 is 2 times of A3. Correct? So if this is going right side with 1 by 1 meters, this will go 2 meter. Okay. Similarly, suppose velocity is 1 meter per second. Suppose. So what is the velocity of this? 2 meter per second. Everything is double. Whatever displacement for this, double. Velocity here double velocity. Acceleration also double. Okay. So next question like this, I will ask in vertical. See, observe this question. This is block A. So now this is point 1. Sorry, point 3 it is. Point 3, this is point 1, point 2. Now I will give velocities. Okay. So suppose this is going down with 2 meter per second. What is the velocity of point 1? Velocity of point 1. So what is the velocity of 2? 0. Good. So this is at rest. So velocity is how to relate velocity? Same formula like acceleration. V1 vector plus V2 vector by 2 is equal to V3 vector. So what is the velocity of 2? 0. V1 you have to find. So V1 plus 0 by 2 is equal to V3. What is V3? Tell me. Downward. So what is V1 by 2? Minus 2. So V1 is equal to minus 4. So suppose point 3 is going down with 2 meter per second. So point 1 will go down with 4 meter per second. Understood? So this will go down with 4 meter per second. Okay, this is on the constraint relation. If you know velocity of 3, you can find velocity of 1. Constraint. Constraint means related. Related. correct? Like suppose two friends, it is like two friends. Suppose two friends are P and Q. I want to know where is Q. I want to know where is Q. They are connected. If you know where is P, means you know where is Q. Both are together like that, you can say P and Q. I don't know where is Q, but I know where is P. So Q will be nearby like that. Constrain, they are connected. Okay, connected bodies. If you know velocity of one point, you can find velocity of other point. Okay, clear? Okay, now answer this. Suppose this is the pulley. Now we are doing one question on laws of motion, correct? So what about tension force? Suppose this is the pulley and one string here and one string here. So this string is pulling with tension T1. So what is tension here? T1. So what is tension here? Tell me. 2T1. 2T1. Because pulley is massless. Remember, pulley is massless. Massless means net force 0. If any object is massless, so what is the net force? 0. Because we know that net force is ma. What is the value of net force? Ma, and mass is 0. So mass is 0. So m into a will be 0. Correct? Okay. So net force 0 means upward and downward equal. So T1 means 2T1. So upward also 2T1. Okay. So now you answer this. Suppose this is 3 kg block. This is 3 kg block. What is the clamp force? Can you answer? What is the clamp force? Force exerted by clamp. How much? 60. Very good. Because what is the tension in this string? What is tension in this string? What is tension in this string? 30. Correct? Tension is upward. 3G downward. 30. So tension is 30. Now if you observe this pulley, so 1T is here. This portion of the string is pulling it down. This portion also pulling it down. Okay. So TT. So clamp force will be 2T. And T is 30. Value of T is 30. So 2T means 60. So clamp is exerting how much force on the pulley? 60. 60 Newton. So remember, here tension, here two times of tension, 2T, T, 2T. Similarly, you can say, if this is T, so how much is these two? T by 2, T by 2. Okay, T by 2, T by 2, T. Okay. T by 2, T by 2, T. Okay, T, 2T. Okay, fine. Clear? Done? Note down. Next, let's solve one question. Suppose this is the pulley. One string is there. Another string is there. And this block mass is M. This force is F. In this question, what is going on? This is the force F. How many strings are there? One string, second string. This string you are pulling it up with what force? F. You are exerting F here. So what is the tension in this string? F. So tension in this string is F. Correct? So what is tension in this portion of the string? This string? T by 2. So F by 2. So for this block, what is the upward force? Tension. And tension is F by 2. Downward force? Mg. Correct or not? So suppose this F is acting upward and the pulley is going down, so block is also going down. So suppose acceleration is upward. So how to find acceleration? this minus this is equal to ma. So you will write T minus mg is equal to ma. So F by 2 minus mg is equal to m. Okay, you can solve like this. Okay, see, this is F. In this string, force is F, tension is F. So here F by 2, F by 2. So for this block, upward is F by 2, downward mg. So F by 2 minus mg is equal to m. Correct? So suppose we have a question, upward force is 100 Newton and this block is 4 kg. Tell me, what is the acceleration? What is the acceleration? Tell me. 4 kg. What is the upward force? Tell me, what is the upward force for 4 kg? Upward force? Here 100 Newton. So what is the force here? 50. 50 Newton. So for block, what is the upward force? 50. So 50 Newton is upward force. What is downward force? 40. Very good. So what is the resultant net force? 50 minus 40 is equal to ma. Correct. Good. So 10 is equal to 4a. So what is the acceleration? 2.5. Acceleration is 2.5. 10 by 4. 10 by 4. Okay, acceleration is 10 by 4. Okay, clear? 5 by 2. 2.5. So this is the force 100 Newton you are exerting here. So pulley will go up. This point will not go. This is at rest. But this point will go up. This point will go up. With what acceleration this point go? 2.5. 2.5 meter per second square. Okay. So constraint relation. Constraint relation. Okay. You understand this. So one pulley is there. 2 points here. 1 point here. Okay. Next. Pulley 100 Newton, 50 Newton, 50 Newton. So this is 4 kg, 50 Newton up, 40 Newton down. So resultant force is equal to mass into acceleration. So acceleration you got 2.5. Okay, 2.5. Okay, done. Any doubt? You understand it? Okay, observe it. How to solve this type of question? Okay, clear? Note down. Now next, one pulley is here, one block is there, say 2 kg. Now here one pulley is there, this is the floor, and here block is there, 1 kg. How many blocks? 2 blocks. How many pulleys? 2 pulleys. How many strings? 1 string, 2 strings. 2 strings. What is the acceleration of this point? 0. What is the acceleration of this point? 0. Correct. Now you tell 2 kg and 1 kg, they will go where? Where they will go? Up, down? Where they will go? Downward? Okay. Suppose we don't know. Suppose we don't know they are moving or not. Suppose you can assume. You can assume they are at rest. Suppose if they are at rest. So what is the downward force here? 10. And what is the upward force? T. Now here T, 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 T. Okay. So what is force here? 2T. 2T means T is 10. T is 10. So what is 2T? 20. So here 2T, here 2T, here also 2T. Okay, same. And 2T is 20. So upward force here 20. And what is the downward force? 2G. 2G means 20. So upward 20, downward also 20. So this is also at rest. So correct only. It is correct. So Both are at rest because here downward 20, so here tension 20, all these points tension 20, tension 20, so here 10, 10, okay, and 10 is balanced with 10, so mg is also 10 here. 1 kg means 10 Newton. 1 kg means 10 Newton. Okay, so they are at rest. Similarly, you can observe this, you can draw this diagram also. This is the clamp pulley. Here mass is 2m. Then what is the mass here? Suppose it is at rest, m. Here mass m, here 2m. So they will move or not? Tell me. They will move or not? They will not move. Here 2m, here m. Because what is the tension here? T. So value mg. Very good. So here mg. So what is tension here? 2 mg. Very good. So tension here 2 mg. Here tension 2 mg. 2 mg. And downward is also 2 mg. Wait. So 2 mg, 2 mg cancel. So system is in equilibrium. System is in equilibrium. System is in equilibrium. Okay. Note down. 2 blocks, 2 pulleys, 2 strings, 2 blocks, 2 pulleys, 2 strings. Okay. Equilibrium. So if this is m, this is 2m. So equilibrium. Now I am changing the mass. What if this is 3 kg? This is 1 kg. Then not in equilibrium. Okay, we'll see. Check. So next, now draw this. Suppose this is 1 kg. This is 3 kg. Suppose this is at rest. So what is tension in this? If they are not moving, so what is tension in this? 10. What is tension in this? 20. Very good. Here tension 20 and downward force 30. So not possible to rest. Rest not possible. So 30 downward, 20 upward. So this will go down. Correct? So this is going down with A. Acceleration A. So what is the acceleration of this point? A upward. Acceleration of this point 0. This is at rest. Okay, this point not going. This is going down with A, so this will go up with A. Okay, understood? If this is going up with A, what is the acceleration of this? It is connected to floor. So 0. This point is rest. So what is the acceleration of this point? If this is going up with A, so this is, tell me, we have done this. How much? 2A or A by 2? We have done this. See this example. This one. Yeah, this type. If this is at rest, this is going with 2. So this is going with 4. This is going with 4. Correct. If this is going with 1 meter per second, so this is going with 2 meter per second. If acceleration is 2 meter per second square, so here acceleration will be 4 meter per second square. So acceleration of this point is A. So what is the acceleration of this point? 2A. This is rest. This is A, so this is 2A. Correct? So let's go back there. So if this is going down with A, So this is going up with A. So what is the acceleration of this point? 2A. 2A upward. Correct? Good. Now, tension. If tension in this string is T, so here 2T, here 2T. Correct? Now draw free body diagram of both block to 3 kg. What is the free body diagram? What is the upward force? 2T. Downward force 30. 3G. Okay, 30. Very good. G is 10. We are assuming G is 10. And free body diagram for 1 kg. What is the upward force? Upward force T. Downward force 1G. Okay. Now what is the acceleration of 1 kg? 2A. Upward. So which is greater, T or 1G? T or 10? T. So you write T minus 10 is equal to MA. So 1 into A. And acceleration how much? 2A. Mass into acceleration. Net force is mass into acceleration. So T minus mg is mass into acceleration. Mass is 1 kg, acceleration is 2A. For this, what do you write? Which is greater, 2T or 30? Which is greater? Acceleration is down. So 30 is greater. So what you write? 30 minus 2T is equal to mass into acceleration. So 3 into A. 30 minus 2T is 3A. And here T minus 10 is 2A. Okay, clear? Are you getting? See, if tension in this is T, what is tension in this? 2T. This is the pulley, T, so this is 2T. So 3 kg upward force is 2T, downward force is 30, and acceleration of 3 kg downward. So 30 minus 2T is 3A. And here what you write? Acceleration is 2A. So T minus 10. T minus 10 is MA. Mass into acceleration, right? What is the mass? 1. Acceleration 2A. Are you getting? Okay. Is it difficult? Observe the steps. Okay. Now solve these two equations. Solve. So you can divide this by 2 or you can multiply this by 2. Tell me what you want to do. I want to cancel T. Okay, multiply this by 2. So you write this like this. So 30 minus 2T is equal to 3A. Now multiply this by 2. Multiply by 2. What you write? 2T minus 10. 2T minus how much? 20. 2T minus 20 is equal to, multiply this by 2, 4A. Okay. Now what do you do? Subtract or add? I want to find acceleration. Add. If you add, what you get? 30 minus 20. 10 is equal to 7A. Correct. Good. So acceleration you got 10 by 7. So what is the acceleration of 3 kg? 10 by 7 meter per second square. And direction? Down. And what is the acceleration of 1 kg? 2A. 2A means 20 by 7. So, so 3 kg goes down with 10 by 7 meter per second square. 1 kg going up with 20 by 7 meter per second square. So this is known as Constrain relation. Okay. So this is very important. So pulley is there. Generally this type of questions, 2 pulleys are there. 1 pulley, 2 pulley. Okay. 2 strings are there. Acceleration of this is A. So this is A downward. So this is A upward. So this is 2A upward. This is 0. This is at rest. Okay, fine. So one important question we have done. Okay. So this is I will take some question from book also. Okay. Just practice this question 3-4 times. You will understand it very well. Okay. So now next. Okay, note down. If you are still copying, write down first. We'll do one question. Give me book from book. Arihant book. Okay. We have Singage also. Errorless. Anyone? Errorless. Errorless. Singage. Okay. Solves. Errorless is also good book. Okay. Correct. Good. And the past year also. So let's see this type of question. We have. You can note down page number. 276. 34. 37. 43. And 3. Page 286. Question 3. So see, let's do this to 34. Okay, page 276, question 34. You have everyone this book? Okay. So see the question. In the figure, pulleys are smooth. Pulleys are smooth. String massless. M1 1 kg, M2 1 by 3 kg. So diagram is there. So see, question number 34. Ceiling. Clamp. One clamp is here. One pulley is here. One string is there. One pulley is there. Another string. Here M3. M1, M2. This is M1. This is M2. M1 is 1 kg, M2 is 1 by 3. M1 is 1 kg, M2 is 1 by 3. You have to find M3. M3 at rest. You have to keep M3 at rest. So what is acceleration of M3? 0. So acceleration of M3 is 0, note down. Acceleration of M3 is 0. If this is not going up and down, 0 acceleration. What is acceleration of this point? 0. Rest. What is acceleration of this point? 0. Rest. Because this is also rest. This is rest. This is rest. So this is also rest. Correct? If this point is not going, so this is also not going. Okay, this is at rest. So what is the acceleration of this pulley? Rest. So this is at rest. Now this question is like this. This question is like this now. We have one block here M1 and another block here M2. Now this everything here up to here everything rest. All these point rest. But M1, M2 same mass or different mass? Different mass. So which is heavy? M1, M2, which is heavy? M1 is heavy, good. So which will go down? M1 will go down, M2 go up. Now find tension in this string. direct formula is there. What is the tension? 2 product G by sum. So what is the product? 1 into 1 by 3, 1 into 1 by 3 into G by sum, 1 plus 1 by 3, 1 plus 1 by 3. So 2 by 3 G by divided by, tell me, 1 plus 1 by 3, tell me, how much? 4 by 3, 4 by 3. So what is the answer? 2 by 3 by 4 by 3, G by 2. So X, G by 2, okay. So 5, G is 5, so 5. Sorry, G is 10, so 10 by 2, 5 Newton. So what is the tension? 5 Newton, 5 Newton, 5 Newton, here 5 Newton, 5 Newton, here 10 Newton, here 5 Newton, 10 Newton, so here 10 Newton, here also 10 Newton. So what is tension here? 10 Newton. So, but it is at rest. So what is downward force? M3G. So both are equal. So how much M3? M3G and 10 equal. M3G is equal to 10. So what is M3? 1. M3 is 1. So M3 is 1 kg. Okay. So you have one block here, rest. This is at rest, pulley at rest. This is going down, this is going up. Tension direct formula 2 M1 M2 G by M1 plus M2. Correct? 2 M1 M2 G by M1 plus M2. 1 and 1 by 3. So product. Okay. 2 product G by sum. Okay, clear? Understood? So note down. Now 2 more we have. 37, 43. You want to try 37? If you have any question, any doubt, you ask. Okay. So this is at rest question. According to question, this is at rest. So rest, rest, rest. All these points rest. Up to here rest. Now this is the pulley. This pulley is at rest. Different masses. So not rest. Heavy, 1 kg heavy. This is light, less mass, more mass. Go down, it will go up. Okay. Tension direct formula. Tension in this is string, direct formula. Here tension T, so here 2T. 5 Newton, so here 10 Newton. 10 Newton, so here also 10 Newton. So upward 10 Newton, downward M3G. M3G 10, so M3 is 1. Okay, clear? Now let's solve 37. 37 like this. So one pulley is there. So what is the force acting on this pulley upward? F. Then you have string passing over it. This is the string. It is fixed here. Other end of the string connected to this pulley, and one string is here. Block is there. The block is M, small m, small m. And then you have other end of the string here, capital M, like this. This is small m, this is capital M. Okay. Two blocks, 5 kg and 10 kg. So small m is given 5 kg. Capital M, what is capital M? 10 kg. This is 5 kg, this is 10 kg. Connected by a string passing over pulley B. This is pulley B. This is pulley B. Pulley B. This is pulley A. Pulley A. Okay, fine. So this string is passing over pulley B. Another string connects center of B. Another string connects center of B, passing over pulley A. Upward force F applied at center of A. Applied at center of A. Upward force. So what is tension in this string? F. What is tension in this? Tell me. F by 2. Very good. Here F by 2. Now here F by 2. This is F by 2. Tell me. So what is this? F by 4. Very good. F by 4. So what is the force? Upward force on capital M? F by 4. What is upward force on small m? F by 4. So small m and capital M. So for small m, upward force is F by 4. Capital M also upward force F by 4. Both pulleys are massless. So accelerations of small m and capital M. You have to find acceleration of small m and capital M. A capital F is given. What is the capital F value? Last line. 300. Okay, this is 300. So what is F by 4? 300 by 4. How much? 75. So F by 4 is 75. Now look at small m. Look at small m. What is the upward force on small m? 75. Downward force mg 50. Okay, wait. So it will go up or not? Tell me. It will go up. So what is the difference? Tell me. 75 minus 50 is equal to MA. 5A. So 5A1. 25 is 5A1. So what is A1? 5. A1 is 5. Note down 5. Now for capital M, upward force is 75. What is the downward force? Mass of capital M 10 kg. What is downward force? Mg. Sir, tell me how much? Mg 100. Which is greater, 75 or 100? 100. So it cannot go up. It is resting. So normal force will act up. Okay, normal force. It is not going up. 100 is greater than 75. It is greater than 75. So capital M will not go up. So it is resting on the floor. So capital M rest on the floor. So capital M rest on floor. Capital M rest. Okay. Capital M rest. So upward force is 75, downward force is 100. 75 is not sufficient to lift it. Okay, to lift. How much minimum force needed to lift it? Weight is 100. How much minimum force? 100. Now 75. So M not lift. Capital M no lift. Okay, no. So what is acceleration of capital M? 0. So which option? Tell me. 5, 0. 5, 0. Okay, clear? First. Okay, 43 is homework. 43 is homework. What is your break time? Tell me. 8:30. Okay. So 43 is homework. Now come to page 286. Page 286. It is looking very big question. Very big question. It is how many pulley? How many pulley? You see the question? 3. How many block? 4 block. How many strings? Strings. 1, 2, 3, 4. The force is also acting. That is also string. 4 strings. It is looking very big question, but it is very easy question. See how? It is easy question. See. Let's draw the diagram. Page 286. Page 286. Here F is given 80 Newton. One string going over this pulley, then one pulley here, one pulley here, another string going over this pulley like this. Now here 1 kg, here 2 kg, here 3 kg, here 4 kg. Now you observe what is tension in here, tell me. What is tension here? This is 80. So what is tension here? 40. Very good. Tension here? 40. So here 40, here 40. Here tension 40. So what is tension here? 20. What is tension here? 20. Here tension 20, here tension 20. So 1 kg, 2 kg, 3 kg, 4 kg. For 1 kg, upward force is 20 Newton. Upward force 20 Newton, upward force 20 Newton, upward force 20 Newton. For 1 kg, what is the downward force? 10 Newton. For 2 kg, what is the downward force? 20 Newton. For 3 kg, downward force? 30 Newton. 4 kg, downward force? 40 Newton. Now 1 kg, upward 20 Newton, downward 10 Newton. So which is greater? 20 greater. So it will accelerate up or down? Up. So for 1 kg, what you write? 20 minus 10. 20 minus 10 is equal to MA. MA means 1 into A1. Okay. So what is A1? What is A1? 10. A1 is 10. For 2 kg, what you write? 20, 20. Upward 20, downward 20. Net force 0. So acceleration 0. A2 0. Difficult? Easy, right? Okay, 3 kg tell, 3 kg. 3 kg. A1 is 10 up, okay, 10 meter per second square. A1 is 10 meter per second square up. Okay, A2 is 0, A3. 3 kg, tell me, 3 kg. Upward 20, downward 30. Which is greater, 20 or 30? 30, what do you write? Is equal to MA. 3A3. 10 is equal to 3A3. So what is A3? 10 by 3. Direction, tell, direction? Downward. And last, 4 kg. Upward 20, downward 40. So what you write? 40 minus 20 is equal to 4A4. So 20 is equal to 4A4. So what is A4? 5. Downward. Okay. So columns are there. Okay. These values are there. Column 1, column 2. You can match it. Okay. Clear? So any past year question? Now come to PYQ. Any PYQ? So no question there. Okay, no problem. Give me your MTG book. Who's MTG? Give me MTG book, blue color. MTG. PYQ. You have PYQ 30 years. carry books with you, okay, always, because in class also we will finish. So I am helping you, right or not? So we are doing in class only. So your time is saved. You can study bio, right or not? No one is having, huh? How? Okay, anyway, time is also over. Okay, we'll continue. Okay, so no one is having one question. I will check. So note down one PYQ I will give. Mass of A 2 kg, mass of B 3 kg, mass of C 1 kg. Find acceleration of all. Find acceleration of all. Okay, you can assume like this. If C is going up, you can assume up or down, both you can assume. A and B both are heavy, 2 and 3. So C is light. You can assume acceleration of C, A upward. What is acceleration of this point? A downward. Now you can assume acceleration of these points. Suppose B is going down with A1. So find acceleration of this point. Okay, use the formula. A1 plus A2 by 2 is equal to A3. Use this. Okay, this is homework. M2 is 2 kg, M1 is 1 kg. Find accelerations. Find acceleration M1, M2. Okay, that's it. Homework. Okay, chalo, that's it. We'll continue.